Hi everyone. This is Dr. S. Venkateswarlu, working as a professor of EC at IARE, Hyderabad. Today we are discussing about linear and digital IC applications. Under this, timers and phase lock loop, or we can consider 565 PLL. Here in this case, block schematic, principles and description of individual blocks, principles and description of 555 timer and 565 PLL phase lock loop. Okay, here this is the today's content. Before entering this we know that all active filters. Supposed you have to remember these active filters. Of that time we are entering that timers. In active filters, an electronic filter is often a frequency selective circuit that passes the specified band of frequencies and blocks or attenuates signals of frequencies outside this band. So filters may be classified in a number of ways. You know, the analog filter, distant filter, a passive, or maybe we can consider that active filters, audio, we can consider AF filter or radio frequency filters. Okay, analog filters are designed to process analog signals, which digital filters process analog signal. Okay, using the solar element used in different construction filter, already we have seen that what you call classifications are now. Passive filters they are using resistor, capacitor, and inductors. And that employed by using active filters, using the transistor, or maybe they are using operation amplifier and inductions to resistor and so on. Okay, so the active filters offer the following advantages over the passive filters. We know that all. So we are supposed to have to recollect these all active filters. Okay, already we have done this, but here by using this all active filters and timers by using this IC version integrated circuits. Okay, so for this case, now we like to enter that our timers. And coming to in terms of these timers, the timer basically we are using that 555 timer. The 555 timer is one of the most popular and versatile integrated circuit or even produced. In industrial applications, there is a great demand for accurate measurement and control of time period. That means people are expecting that what you call accuracy in terms of parameters like measurements and control of the time period. This can be achieved by using the time delay circuits to connect or maybe disconnect power supply from load, because of we are verifying that accuracy measurements when initiating that signal. So the signal lapsed after the predetermined the time period. So due to the solar Signetics Corporation first introduced these devices as the SE Signetics SE 355 or 556 solar timers. If we have to consider that all 355 timer minus 55 degrees centigrade to 125 degrees centigrade, it is sustained. Where any the 355 timer 0 degrees centigrade to 70 degrees centigrade in early 1970s. It is a combination of digital analog circuits. Okay, it is a combination of the digital and analog circuits and known as, you can consider this the time machine. So based on that, the timers, we have to consider time machine with the help of the timers like 355 timer, or it is a combination of digital and analog circuits. So it is a combination of digital analog circuits and known as the time machine. Okay, the 355 timer features, it can provide time delay from microseconds to hours. So always they are using this type of features. Okay, it operates with the power supply of plus 5 volts to plus 18 volts. But normally in the practical purpose, there is a plus or minus 0 to what you call 15 volts, but here it is it operates with the power supply of plus 5 volts to plus 18 volts. Yeah, it can drive a load up to the 200 milliamperes. Okay, it has an adjustable duty cycle. Okay, it has high current output due to compared to other devices. It is compatible with both TTL transistor logic and CMOS logic circuits. In 555 timer, it is reliable, yeah, easy to use and low cost. That's why always they're in the 555 time. If it is any real time, what you call real time or industry purpose, they are designing what you call product based products or what you call real time products. All are without this 555 time, they're able to design. They are unable to fabricate what you call equipment or devices and so on. Yeah, in the timer, yeah, this is the pin out diagram of 555 timer. Yeah, basically we are having that what do you call 8 pins. First pin is followed by ground, second pin is trigger, third pin is output, fourth pin is reset, fifth pin is control voltage, sixth threshold, and seventh is discharge. Finally, the eighth pin is plus VCC. Okay, this is the pin out diagram. Pin configuration. So the dot is mentioned. Suppose you have to what you call count it, but the dot. Okay. So here this is the function. This is the pin out diagram. Click on the pin out diagram. This is a block diagram. Here it is. How many here comparators are there? It's around 2 comparators. How many transistors are there? Yeah, here 2 transistors are available in input section. One transistor Q1 in output section is Q2. Comparator input section first comparator, output section is second comparator. They are using the flip-flop. Okay, so this is the function block diagram of the timer with the help of what you call pin-out diagram easily can analyze. Yeah, using this all function block diagram where all each and every pins are involved here because of already we have seen that pin-out diagram of 555 timer. So fifth pin to up to 8th pin it is assigned. First pin is ground. Okay, so the seventh pin is the seventh pin is connected to the capacitor and T1. Okay, second pin is connected with the operation amp for inverting. Terminal is connected to the trigger. And third pin is connected to the output. Fourth pin is reset. Fifth pin is connected to the what you call upper comparator inverting terminal. Okay, that is it is observed that. Okay, and the sixth pin is connected to the upper comparator what you call non-inverting terminal. Okay, seventh pin is connected to the T1, the transistor. Okay, collector terminal is connected to the seventh pin. Eighth pin is connected to the what you call that VCC. Okay, like this here, the 555 timer is one of the what you call most popular and versatile integrated circuits you have produced. Signetics, already we have seen that Signetics Corporation first introduced this device as the NE355 in the early 1970s. It is the combination of digital analog circuits. It is known as the time measure as it is performs a wide variety of time tasks like applications of for the 555 timer. It includes ramp and square wave generator, frequency dividers, voltage control oscillator, pulse generators, and LED flashers. Okay, like this is the 555 timer pin out diagram. Here check it the NE 555N. Okay, the 555 timer is an 8-pin DIL, so integrated circuit or chip. Okay, here it is right side there is the pin out diagram. The physically it is the notch is also observed. Within this, you can count the pin number from ground to VCC. First pin is ground, trigger, second pin, third pin is output, fourth pin is reset, and fifth pin is control voltage, and physically it is user can observe this one, and sixth pin is threshold, and seventh pin is recharge. Finally, that VCC is 8th pin. Okay, this is the 555 timer pin description where here it is ground. Yeah, the pin number 1, this is ground or low level, maybe you can consider 0 volts. Second pin is the trigger. Output rise and interval starts when this input falls below 1/3 VCC. Okay, once we are connecting that pin number 2. Come to the third pin, that is output. Here this output is driven to the approximately 1.7 volts below plus or minus plus VCC or ground. The fourth pin is reset. A timing interval may be reset by driving this input to the ground, but the timing does not begin again until what you call reset rises above approximately what you call 0.7 volts. So where this override this trigger which overrides threshold, coming to the fifth pin control CTRL, access to internal voltage divider by default 2/3 VCC. Okay. Sixth pin, what you call sixth pin threshold, the interval ends when the voltage at threshold is greater than at control. Okay. And seventh pin, what you call the open collector output may discharge a capacitor between intervals in phase with output. The last pin is VCC. Eighth pin is VCC. Positive supply voltage is usually between 3 and 15 volts. This is the 355 timer pin description. Already we know that our pin diagram with reference to that. Each and every pin from first pin to eighth pin, what purpose they are using, which pin is purposefully how they are using by using these 355 timer pin descriptions. Okay. So this is the IC 355 timer. Why 355 timer? Because of it is two comparators, flip-flops. There is the RS flip-flop. Okay, that control voltage come to the fifth pin and sixth pin threshold voltage. Second pin is what you call trigger voltage come to the comparator 2 and comparator inverting terminal. The comparator non-inverting terminal is connected with this 5 kilo ohm, like comparator 1 and comparator 2 to the grounded. So all are connected. Comparator 1 is connected to the reset. Comparator 2 is connected to the set. Okay. Now based on this all our output is connected. T bar is connected to that T1. So we have to verify that output response. This is the schematic diagram of 3-4 timer. Based on the schematic diagram, how many transistors are available, how many resistors, if it is capacitors are available, and okay, like this, you can observe the schematic diagram of 3-4 timer. So before that, there is a block diagram. Based on the block diagram, usually we will observe that 3-4 timer, what you call pin-out diagram. Based on this all, how they are fabricated. There is a single stone or IC version. So once we are having this schematic diagram of 3-4 timer, you can justify this pin-out block diagram and schematic diagram. With the help of the schematic diagram of 3-4 timer, you can justify each and every what we call pins, how it is connected, how we are utilizing that on the description or whatever it is. Okay. Yeah, in the 3-4 timer, yeah, it contains 25 transistors. If you are scan this diagram, how many transistors are there? So you want to verify, connect this one. How many transistors you can connect? Transistor and the capacitor or maybe other electronics components. Here it is specified. It contains 25 transistors, 2 diodes, and 16 resistors. Isn't it? As per this functional block diagram of 3-4 timer, you can observe that description based on that each and every electronics components. It contains 25 transistors, 2 diodes, and 16 resistors. Maximum operating voltage is 16 volts. Maximum output current 200 milliamperes. Within this, best treated as the single what you call component with required input and output using this block diagram. Input contains signals, they will be produced or controlled in a what you call a proper manner and will produce the known output. So using this all description is going to identify that how many electronics components are involved. What the top rating voltage, based on that what the maximum output to current. Okay, it is specified our typical value. If the current is 200 milliampere, operating voltage is 16 volts. Like this, inside the 3 timer, here the function diagram with reference to the function block diagram of 3 timer. So using this all is a flip flop. If it is using this the control flip flop, S is 0, R equal to 0. The Q and Q bar is no change. If S equal to 0 and R equal to 1, Q is 0, Q bar is 1. Okay, similarly that S equal to 1, R equal to 0, Q is 1, Q bar equal to 0. Okay, like that S equal to 1, 1 and Q bar equals, okay, like this, you have to observe this. Okay, this is the main operation through timer. The voltage divider has 3 equal 5K resistor. It divides the input voltage VCC into three equal parts, like the comparator or the op amps that compare the voltage at their inputs and saturate the depending on which is greater. The threshold comparator saturates when the voltage. The voltage at the threshold pin number 6 is greater than 2/3 VCC. Okay, this is interpretation. The trigger comparator saturates when the voltage at the trigger pin number 2 is less than 1/3 VCC. Okay, so inside this timer, the flip flop is a bistable device. Yeah, it generates the two values. A high value equal to the VCC and a low value is equal to 0 volts. The threshold comparator saturates. The flip flop is what you call reset and it output as a low signal at pin number 3. Okay, so then the trigger comparator saturates. The flip flop is set. Okay, and it outputs a high signal at pin number 3. The time the transistor is being used as a switch. Using when the threshold comparator saturates, the flip flop is what you call reset and it outputs a low signal at pin number 3. Okay, the transistor is being used as a switch. It connects in pin number 7 to ground when it is closed. Then when Q is low, Q bar is high. We have verified the truth table. So this closes the transistor switch and what you call attach this pin number 7 to ground. When Q is high, Q bar is low. This open the switch and pin number 7 is no longer grounded. This is the inside of the 355 timer. Okay, uses of the 355 timer. What the 355 timer is used for to switch on or off an output after a certain time delay. How is time delay? That is, it is identified. So real time purpose, they are in the game timer, child's mobile, and exercise timer. Okay, other applications. What the timer is used for to continually switch on and off an output, that is warning lights, scale indicators, and as a pulse generator, that is to provide the series of clock pulses for a counter. Okay, and 355 timer operating modes. The 355 timer has 3 operating modes. One is monostable multivibrator, unstable multivibrator. Third one is bistable multivibrator. It's all monostable, unstable, bistable. They are used. Previously, we are using that by using the transistor version. Now we are using this particular IC version. In place of previous courses, we have learned that monostable, unstable, bistable by using transistors. But here in this case, by using ICs, for timer. So what are the output response? The output response is same or different? Using the discrete version or IC version, which one is suitable for our present technology or future technologies? Okay. Yeah. By using this op-amp monostable, so op-amp monostable multivibrators are electronic circuit, which produces the particular single time rectangular output pulse when externally triggered. Okay, monostable circuits can easily be made using the discrete components or digital logic gates. Monostable circuits can also be constructed using operational amplifiers. Okay, op-amp operational amplifier monostable multivibrator. We can consider that one shot multivibrator or single shot multivibrator circuits or positive feedback or regenerative switching circuits that have only one stable state, producing an output pulse of an specified particular duration t. Okay, so external trigger signal is applied for it is changed state, and after a set of period of time, either in microseconds or in milliseconds or seconds, a time period which is determined by RC component, resistor capacitor components like our electronics components. The monostable circuit then returns back to its original stable state, where it remains until the next trigger input signal is arrives. Okay, so you can observe this type of operations. Okay, with the help of this simple block diagram. Here RC timing circuit, it is followed by R and C. Connected this resistor and capacitor is connected to the switching circuit. Okay, input section is triggered input. Here it is. There is a possibility positive going transition or negative going transition. Where T is equal to 0, the negative going transitions are appear like this one. This is the trigger input. After using RC timing circuit and switching circuits, we will expect that all output. So it is the stable or unstable, or stable or unstable is observed by using operational amplifier monostable multivibrator. Using this simple block diagram, okay, the above block diagram, this block diagram shows that the monostable multivibrator is constructed by adding an external resistor, that is available RC time network, and capacitor across the switching circuit. The switching circuit can be made using here there is a possibility using resistor, digital logic gates, or general purpose operational amplifiers. The time constant tau of the resistor capacitor combination determines the length of the pulse t. In this using this all using block diagram, you can consider that all where go on substituting all value r equal to g, r equal to different values, and c equal to different values. You ensure the t equal to 0, where t equal to 1, 2, 3, and so on. Using this tutorial, we will construct a monostable multivibrator circuit using an operational amplifier comparator circuit. Okay, here with a positive feedback path, as the feedback is positive, the circuit is considered regenerative. What you call regenerative? That is, it adds to the differential input signal. Okay, there will be a timer as a monostable multivibrator. Here, this is the circuit diagram through for a timer. The fifth pin is connected with the capacitor. Okay, 4th pin RA, 8th pin is connected to the VCC, 7th pin is discharge, 6th pin is threshold, 2nd pin is connected with this trigger input. Okay, RA is connected with this capacitor, with the 1st pin is connected to the ground. Third pin is connected to the output, V out. This is the simple block diagram of monostable multivibrator using 355 timer. Okay, with reference to this block diagram, in the standby state, flip-flop holds the transistor key 1 on. Where is the flip-flop? It is a click on this 355 timer block diagram or functional block diagram. The what you call flip-flops are available. Flip-flops holds transistor key 1 on, thus clamping the external timing capacitor C to ground. Okay, the output remains at ground potential, that is low. Okay, as the trigger passes through VCC, 1/3 VCC, the flip-flop is set, that is Q bar equal to 0. Then the transistor Q1 is off and the short circuit across the timing capacitor C is released. As Q bar is low, output goes high. Like this, that interpretation, output response is verified. There is an influence that is affected with what you call flip-flop. Okay, the timer as a monostable multivibrator. Here, in this case, the timer in a monostable operation with the function block diagram. Here it is upper comparator and lower comparator. Here also there is the T1, transistor 1, transistor 2 with control flip-flop, power output as per your 355 timer. The trigger is additional pulse has no effect on output. Yeah, that capacitor voltage 2/3 VCC and output is 0 plus VCC reset. So here it is plus VCC 0 plus VCC. Reset pulse applied during the timing interval terminals. The upper output pulse will be appeared like this will verify that output wave form of the monostable multivibrator using 355 timer. Okay, monostable multivibrator. Yeah, there is a voltage across it rises exponentially through R towards VCC with the time constant RC. After time period T, the capacitor voltage is just greater than 2/3 VCC. And the upper comparator reset the flip-flop. Yeah, that is what you call R equal to 1, S equal to 0. Yeah, this makes Q bar is equal to 1, C rapidly to ground. Okay, so within this, the voltage across the capacitor is given by, so mathematically, if negative going reset pulse terminal pin 4 is applied, then the transistor Q2 off, Q1 is on, and then the external timing capacitor C is immediately discharged. Due to this, all are VCC ready to calculate, where VCC is equal to VCC of 1 minus e power minus t by RC. Okay, at this T, where T is equal to capital T, VC equal to 1/3 VCC. Now 2/3 VCC equal to VCC of 1 minus e power minus capital T by RC, where capital T is RC into ln 1/3, where capital T is ready to calculate, where capital T is equal to 1.1 RC seconds. This is the monostable multivibrator using the 355 timer operation. So both in mathematical notation, now they are calculating that VC and capital T and so on. Okay, what the behavior of the monostable multivibrator? The monostable multivibrator is constructed adding an external capacitor and resistor to a 355 timer. Already we have seen by the help of that block diagram. Okay, circuit generates a single pulse of the desired what you call duration when it receives a trigger signal. Hence, it is also called as one shot or single shot. That's why monostable multivibrator is. So behavior is what you call it when it receives the trigger signal. Hence, it is also called as one shot or single shot. If the time constant of the resistor or capacitor, okay, combination of it determines the length of the pulse. Like this, monostable multivibrator is estimate. That's all parameter. Uses of the monostable multivibrator used to generate a what you call clean pulse of the correct height and duration for the digital system. That purpose there is the monostable multivibrator using 555 timer. Okay. Next, used to turn circuits or external components on or what you call off for a specific length of time. Used to generate the delays. That purpose of the monostable multivibrator using timer can be cascaded to create a variety of sequential timing pulses. These pulses can allow you to time and sequence a number of related operations. How they are operating. So we are using this in the monostable multivibrator of as per the circuit diagram where R is assigned here, where R value is equal to 100 kilo ohm and the time delay capital T. Okay, the capital T equal to what you call 100 milliseconds. Calculate the value of C. Yeah, easily can calculate the capacitor value with the help of the monostable multivibrator using 315 timer. Yeah, like we have to consider the circuit diagram. We know that all circuit diagram. To this, how they are calculating that. Given data is R is given, isn't it? R is given. What do you call R is given? Okay, and T is also given. Right to calculate what do you call capacitor. Okay, how? Based on the given data is the C, we know that one C equal to T by 1 plus 1.1 R. Where T is, it is specified that where T equal to 1.1 RC. Okay, where is you can calculate the capacitor. Where C is equal to capital T by 1.1 R. It is you can calculate that capacitor value approximately. C is equal to capital T by 1.1 R. Where T is, we know that 1 into T is given 100 milliseconds, 100 into 10 power minus 3, 1.1 into R is given. How much that R value? Where R equal to 100 kilo ohm, 1.1 into 100 into 10 power minus 3. So, we can try to calculate that what we call the capacitor value, 0.9 microfarads. Okay, like this, try to calculate. What are the applications in the monostable multivibrator using the 255 timer? Where it is used? It is purposefully missing pulse detector. Something is missing, like a pulse. The missing pulse detector purpose. We call the monostable multivibrator using 355 timer. Next application is linear ramp generator. Third one, frequency divider. Fourth one, pulse width modulation. Okay, missing pulse detector. Here it is. A missing pulse detector monostable circuit. Yeah, there is output response here using 355 timer, using this all block diagram. Each and every pin is connected. First pin is ground, and what you call third pin is connected to V0, and eighth pin is VCC, fourth pin is reset, second pin is trigger, seventh pin is recharge, sixth pin is threshold. So that all seventh pin and sixth and second pin is connected to the input, and what you call fourth pin is and eighth pin is connected to the VCC 5 volts. The transistor is connected to sixth pin with the base, collector. Base is connected with what you call VIN input. Within this, that input is what you call the missing. Here it is. The pulse is input is applied VIN. Here something is pulse is missing. Missing pulse is completed here. Okay. The time we record the monostable multivibrator using 355 timer. A missing pulse detector description here. When input trigger is low, emitter-based diode of Q is forward biased, capacitor is clamped to 0.7 volts of diode. Output of the timer is high, width of T, output of the timer greater than trigger pulse width. Okay, so here where capital T is equal to 1.1 RC, select the R and C such that T greater than trigger pulse. Okay, within this, the input, what do you call that? Output will be high during the successive combining of the input, what do you call input trigger pulse. If one of the input trigger pulse missing trigger input is high, Q is cut off. Timer acts as a what do you call normal monostable state. Yeah, by using this simple block diagram, you can observe that missing pulse detector operation, description, interpretation. Usually can what do you call the timer acts as a normal monostable state. Okay, yeah, it can be used for speed control and measurement. Yeah, industrial purpose, it is very much used for speed control and measurements. Yeah, coming to the next second application, linear ramp generator. That linear ramp generator here it is 3 for timer. Yeah, first pin is connected to the ground, fifth pin is connected to the capacitor 0.01 microfarad, seventh pin connected with the output. Okay, with the help of that capacitor, and eighth pin and fourth pin is connected to the VCC. Second pin is connected to the trigger. Okay, that output is connected with the VCC with the RF and R2, R1 and R2. The transistor is base is connected with R1 and R2. Okay, base and emitter. Okay, emitter is RE and V, and base is connected with this output VO. So within this, trigger is trigger at pin number 2, like 2 greater than VCC, one-third VCC trigger. You have to apply here input, output to right to observe that one. Like a trigger and ramp waveform. The capacitor voltage at pin number 6. Due to this, ramp generator using the timer, 3 timer. Okay, this is the simple circuit diagram. We'll try to verify that output response like this. What that is? Linear ramp generator description here. You have to analyze with the help of the same circuit diagram. Apply the KVL, Kirchhoff voltage law, around the base emitter loop of Q3. Okay, and where R1 by R1 plus R2 into VCC with reference to that circuit, because of we are applying the KVL. Okay, where VB is equal to IE, that is V equal to IR, based on that VB is equal to IE into RE is also equal to that IC of IB into RE is also equal to IB into beta plus IB into RE is also equal to 1 plus beta into IB, and RE is equal to beta. That amplification factor IB into RE approximately collector current product with emitter resistor is also equal to I into RE. Like this, you have to easily can simplify that mathematical notation. Is to calculate that current voltage capacitor. If it is applying this integration here, and IC integral 0 to t IDT is equal to 1 by C into integral 0 to t. So R1 into VCC minus VBE, VCC minus VBE, R1 plus R2 by RE of R1 plus R2 into dt. Okay, after simplifying this 1 by C, so when VC becomes 2/3 VCC at t, so 2/3 VCC where R1 VCC minus VBE of R1 plus R2 into t by C or E of R1 plus R2. So therefore capital T is equal to 2/3 VCC into C into RE of R1 plus R2 by R1 into VCC minus VBE of R1 plus R2. Next, third application, frequency divider. Here that using the same 3 timer is based on this circuit diagram of frequency divider. Okay, for that fourth and eighth pin is connected that what you call 15 volts, and seventh pin is connected to R1. Okay, and the sixth pin connected to the capacitor C1. Fifth pin is connected to the capacitor C2 times 0.047 microfarad. So third pin is connected to the output, second pin is input is connected. A continuously triggered monostable circuit, when triggered by a square wave generator, can be used as a frequency divider. Yeah, if the timing interval is adjusted to be longer than the period of the triggering square wave input signal, okay, the monostable multivibrator will be triggered by the first negative going transition. Okay, we know that all positive going transition, negative going transition. Here it is the positive going transitions are like this, and negative going transitions are like this, using the solid calendar. Okay, yeah, the monostable multivibrator will be triggered by the first negative going transition edge of the square wave input, but the output will remain high because of greater timing interval for the next negative going edge of the input square wave as per this block diagram of the frequency divider. Okay, next coming to the fourth application, pulse width modulation. Using the same IC, that is followed by LM355 timer. First pin is connected to the ground with the capacitor. The capacitor other end is connected to the threshold, sixth pin. Okay, seventh pin is connected to the discharge. Okay, it is connected to the RA, connected to the VCC with the fourth pin and eighth pin. Second pin is triggered, third pin is output. This is a simple circuit diagram. Based on that, it is pulse width modulation. So with the help of this, the trigger is upward, input trigger is upward. Okay, output is right on that modulated input T versus V. The pulse width modulation output is T versus V naught is like this. The right to pulse width modulation waveform will be observed. Okay, pulse width modulation. Here the charging of using this all block diagram. Here with the help of this consider this pulse width modulation diagram. The charging time of the capacitor is entirely depends upon 2/3 VCC, but capacitor voltage just reaches about 2/3 VCC. Output of the timer is coming from the high to low level. This is one major operation. We can control this charging time of the capacitor by adding what you call continuously varying the signal to pin number 5 of the triple timer, which is denoted as the control voltage point. Now each time the capacitor voltage compared control voltage according to the output pulse width change. Okay, output pulse width is changing according to the signal applied to the what you call control voltage point. So the output is pulse width modulation form with reference to that block diagram. Where the signal at the pin number 5 of the timer, which is what you call denoted as the control voltage point. Okay, this is the pulse width modulation circuit. This is the practical representation. Already we have learned the previous courses under digital communication, and here it's supposed to have remember that how it is expanded the pulse width modulation waveform with the help of the pulse width modulation. Okay, second pin is connected to the pulse trigger input, fifth pin is control voltage by varying that what you call modulation input V 3.3 volts. Fourth and eighth pin is connected to the ground, what you call VCC. Okay, recharge threshold is connected to sixth and seventh pin, and third pin is output. I'm supposed to verify that output of pulse width modulation output response. Okay, now coming to the stable multivibrator. Here, this is the simple block diagram. Compare that stable or monostable and unstable. So first pin is here, it is connected. Fifth pin is capacitor 0.1 microfarad. Second pin and sixth pin is connected with RA and RB with this capacitor. Seventh pin also connected to the RA with the RB. So fourth and the fifth, eighth pin is connected to the plus 5 volts. Third pin is connected to the output. Here, where it T1 is, it is specified, the T1 width is 0.693 RB into C. T2 is equal to 0.693 RA plus RB into C. The T is equal to T1 plus T2, frequency is equal to 1 by reciprocal of the time. Due to cycle, try to calculate T2 by small t2 by capital T into 100 percentage. RA is given. The RA value is 1 kilo ohm. That RB is also given, that RA plus RB should be less than or equal to 6.6 ohm, where the capacity is 500 picofarad. Okay, here using this all pinout diagram, a stable multivibrator is constructed. Yeah, a stable multivibrator. This is the function block diagram of a stable multivibrator using a table for timer. Okay, here, here there is a description or interpretation of the previous diagram. Connect the external timing capacitor between the trigger point pin number 2 and ground. Split external timing resistor R1 into RA and RB and connect the junctions to discharge terminal 7, pin number 7 here. Okay, so now remove the trigger input. Monostable is converted into a stable multivibrator. This circuit has no stable state. Okay, the circuit changes its state alternatively, hence the operation is also called as free running oscillator. Alright, the stable multivibrator is free running oscillator. Why it is? So here, this trigger input monostable is converted to a stable multivibrator. The circuit has no stable state. The circuit changes its state alternatively, hence the operation is also called as free running oscillator, or you can consider free running state. Okay, a stable multivibrator using simplified timer block diagram contains here resistive voltage divider equal to resistor. Set the threshold voltage for the comparator where V1 is equal to V threshold. It is also typically it is 2/3 VCC where V2 is equal to V threshold is 1/3 VCC. Two voltage comparators for V1 if V plus greater than VH, then R is equal to high. Where if it is for A2, if V negative less than V threshold, then S is equal to high. Why is always there in the flip flop? Because of internal block diagram of three-field timer. Using the flip flop where R is equal to I, S equal to high is observed. In RS flip flop, if S is equal to high, then flip flop is set. The time Q bar is low, Q1 is off, output voltage is high. You know that one. If R is equal to high, then flip flop is reset, Q bar is equal to high, Q1 is on, output voltage is equal to low. Yeah, here transistor Q1 is used as a switch. Okay, like this, that operation is involved. Assume that initially that the capacitor is discharged for A1, V plus equal to VCC is equal to VC is equal to 0 volts, and for A2, V minus is equal to VC is equal to 0 volts. So R is equal to low. Because of R we have seen, if S is equal to high, Q bar is equal to low, Q1 is off, output voltage V out is equal to VCC. Okay, next, now as the capacitor charges through RA and RB, so here it is eventually VC greater than V threshold level, so where R is equal to low and S is equal to low. Yeah, that flip flop does not change the state. Like that, here we have to verify that RA value and RB value is calculated. Next, the next condition, once VCC greater than or equal to V threshold, where R is equal to high, S is equal to low, the time Q bar is equal to high, Q1 is on, output voltage is equal to 0. Next, capacitor is now charging through RB and Q1 to ground. Meanwhile, at flip-flop, R is equal to low and S is equal to low, since VC less than V threshold. Using this all analysis, easily can observe that operation of 555 timer, a stable multivibrator. Next condition, once VCC less than V threshold, the time where R equal to low, S equal to high, Q bar is equal to low, Q1 off, V out is equal to VCC. The capacitor is now charging through RA and RB again. Here, using the simple circuit diagram, user can operate this one based on that all three conditions. Okay, the timing diagram of triple timer, a stable multivibrator, user can observe that what you call output waveform. 2/3 VCC VC of T V threshold, 1/3 VCC V threshold VTL, and 1 and 2 condition. Third condition also, the capacitor is now capacitor voltage will be absorbed. It is followed by T versus VC of T. Like that, using this all, now it is charging period and discharging period is can observe where T equal to 0, where T equal to dash, and TL and TH, output voltage of IC. This is the finalized timing diagram of a 555 timer, a stable multivibrator. Output is equal to high. How? Here, T high is equal to calculation for the oscillators high time. Here it is by using that all previous output waveform. Consider here. Here, this case, the output is high while the capacitor is charging through RA plus RB. Now here it is observed the charging and threshold where T high is equal to 0.693 RA plus RB into C. Okay, like this output is the output is equal to low, is you can observe here like this. Now the period is total time of on and off cycle, and depends on the value of RA and RB. You can estimate that on capacitor voltage, output voltages, so it is varies similarly in frequency. Like it is a stable multivibrator, you can analyze using the mathematical notation of this. The capacitor voltage, they are what we call VC. VC is equal to VCC of 1 minus e power minus t by RC. The time t taken by the circuit to change from 0 to 2/3 VCC is VC is equal to 2/3 VCC, where 2/3 VCC is equal to VCC of 1 minus e power minus t1 by RC, okay, by 3. This where VC is equal to 1/3 VCC. Like this, try to calculate the T2 value. Okay, so the time to change from the VCC by 3 to 2/3 VCC is T high is equal to T1 minus T2. It is followed by, the T1 value 1.09 RC minus, that T2 is equal to 0.405 RC, and where T high is equal to 0.69 RC. So for the given circuit, T high value is 0.69 RA plus RB into C. Now the charging time will be observed. Okay, the output is low while the capacitor recharges from the 2/3 VCC to 1/3 VCC, and the voltage of the capacitor is given by VCC by 3 2/3 VCC e power minus t by RC. Like that, you can analyze if we get the T is equal to 0.69 RC for the given circuit. So how it is discharging, total time period T is ready to calculate of that T value is finalized. Okay, frequency F is equal to 1 by T. Finally, it is assigned 1.45 is the error constant. Error constant is right observed after get that where T is equal to 0.69 into RC. Okay. So after that, try to calculate the D value, percentage of D, that is duty cycle. T high by capital T into 100. Okay, is calculate the duty cycle. But the behavior of the stable multivibrator. Why we are using this all interpretation, what do you call numerically and mathematically and so on. There is a lot of behavior of the stable multivibrator. The stable multivibrator is simply as an oscillator because of the free running state. The stable multivibrator generates a continuous stream of a rectangular of on pulse that switches between the two, two stage or two voltage levels. Like this, the frequency of the pulses and their duty cycle are dependent upon the R and C network values. Yeah, the capacitor C charges through the series resistor RA and RB with a time constant RA plus RB into C. The capacitor discharges through RB with the time constant of RB into C. Yeah, this is the major three levels of the behavior of the stable multivibrator using 355 timer. Okay, like this, the timers already it is observed. This all are calculated. Okay, what are the applications of a stable multivibrator? In applications, a stable multivibrator, square wave generator, FSK generator, pulse position modulator. Okay, it is very much useful in in communications, analog communication, and digital communications. Next, square wave generator. We are using the same 3 timer. So, we can to avoid the excessive discharge current through a Q1 when KR1 equal to 0. This is a simple circuit diagram based on the duty cycle. If it is R1 equal to 0, yeah, it is connected to the diode across R2, place a variable R in place of R1, charging path R1 and D, discharge path R1, pin number 7. As per this circuit diagram, square wave generator using 355 timer. FSK generator here. Using the 355 timer, 6th pin and 7th pin is connected to the capacitor with the R1 and R2. It is 7th pin is connected to the R3 and T1 transistor 1. The base is connected with the pulse RB, digital input at 150 kHz. So 8th pin and 4th pin is connected to plus V. Okay, 3rd pin is connected to output, 5th pin is C2, capacitor 2. Of course, 2nd pin is connected to C1 or C. So in a digital data communication, binary code is transmitted by shifting the carrier frequency between two preset frequencies. This type of transmission is called frequency shift keying technique. Yeah, FSK generator. A 355 timer is a stable mode can be used to generate FSK signal when inputs digital data is high, T1 is off, and 355 timer works as a normal stable multivibrator. Okay, the frequency of the output waveform given by F0 is equal to 1.4 pi by R1 plus 2R into C. When input digital is low, Q1 is on, then R3 is parallel R1. Therefore, F0 is equal to, try to calculate 1.45 R3 parallel with R1 plus 2R into C. Okay, like this. 355 timer is a stable mode can be used to generate FSK signal. How? When input digital data is high, T1 is off, and 355 timer works as the normal stable multivibrator. Like this. The frequency of the output waveform given by F0 is equal to 1.45 by R1 plus 2R2 into C. So when the input signal is low, Q1 is on, then R3 parallel R1. Therefore, F naught is calculated, where 1.45 by R3 parallel R1 plus 2R2 into C. Okay, so like this, the what you call the 555 timer, based on this timer, 555 timer application and so on. So what the main operation and pinboard diagram, function mark diagram, and so on, what the application and so on, just to be verified. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.